Hello everyone, I'm Greg and I'm here to tell you a story about how a large cluster, a Ceph cluster, went wrong and what we did about it. First of all, a little about me. I'm a generalist Linux sysadmin with an interest in people and processes, the four opens of the Open Infra Foundation, and running technology service as well. My work at Pawsey is mainly to lead the team who manage our Ceph object storage clusters and to help manage our OpenStack cloud service. Pawsey is one of two Tier 1 high-performance computing facilities in Australia, and our work is to provide computing services to accelerate scientific research for the benefit of the nation. Our supercomputing, data, cloud and visualization services support research across a spread of scientific domains. This all runs on equipment in our data centre in Western Australia. In recent years, Pawsey has shifted from mostly using cluster file systems to a central Ceph object storage system. This significant change resulted in the successful design and implementation of a system called Acacia, leaving Pawsey well positioned for years to come. Today I'm talking about the larger of these two clusters called Acacia Ingest, which was built with particularly high resilience for precious radio astronomy data. Pawsey has even more motivation for resilient design than the norm, because we are funded such that we only work Monday to Friday, 9 to 5. So if there's a problem, we come back to it the next morning. I'll give some background now to the situation we faced late last year and some of the risks and problems we faced. The system was technically sound and had seen strong uptake by researchers in its first years in production. However, during handover to a new system owner, something which will always carry some risk, some challenges emerged. Limited skilled staff, combined with other factors, contributed to gaps in system maturity, underdeveloped team practices, and technical debt from an incomplete migration to new tools. Further, the radio astronomy ingest cluster was degraded and unbalanced due to some complete node failures, and it had not been health okay for 7 weeks. Cluster growth resulted in an unhealthy distribution of placement groups, with each OSD holding between 50 and 90 PGs. For reference, 100 is the recommended minimum, so we really needed to double our PG count. And on a large cluster, that was going to take a while. The deviation of plus or minus 20 that you might see there was also far too high, since it should be about 1. That graph should really be a single bar somewhere well over the 100. On a Friday night in early December, the main cooling services to the building went offline, and Friday night, as I've indicated earlier, that's a big problem because we're not seeing it till Monday morning. However, we do have an alert system, but due to a number of system and process failures, alert notification was delayed. By the time a message was received and Pawsey staff arrived on Saturday morning, the situation was unrecoverable, and the emergency power off button was pushed. Door handles were hot to touch, air temperature reached 60 degrees Celsius, and the surface layer of some of our heavy-duty floor tiles began to separate. While it was bothersome and unfortunate to have a sudden and complete service outage, recovery was actually quite straightforward. Once building and other underlying systems were back online, we brought Ceph online, checking each of the machines and services as we went. There was hardware failure, but not enough to make any data unavailable. Because we had two main production clusters and varied skills across the team, we took the opportunity to train people in using the startup procedures. For the next few months, we had increased rate of drive failures, but that then settled down to a typical rate. We also had a real uptick in flash drive failures in this time, which until then had been, normal flash drive reliability. But that leads me to wonder if flash drives are more vulnerable to heat stress than HDDs. With the cluster back online, backfilling and scrubbing continued on the path to health OK status. During this phase, the team had differing opinions on the best approach to managing the cluster. In hindsight, while neither of the main strategies was inherently wrong or made the cluster's state worse, that debate consumed energy that could have been better focused elsewhere and led to some unnecessary data movement. It also contributed to us overlooking the fact that one rack had an entire node offline. Nevertheless, Ceph's automated rebalancing mechanisms gradually improved the situation, though we did have some concerns about how long it would all take. Fast forward to January, and all equipment at Pawsey was turned off for site electrical works. Upon return to service, everything initially went smoothly, though we knew this cluster still had significant rebalancing work to do. Suddenly, Rados gateway errors began to appear. A few weeks earlier, we had seen similar but intermittent issues with excessive RAM usage, temporarily resolved by restarts. We knew that was just a stopgap until we could investigate further, but now the failures were becoming more frequent. Increasing the allocated RAM didn't give much relief. Now we faced an attention problem. Initially, we were uncertain whether we were facing terrible performance or whether there was an actual system failure, so we split our efforts to look at both possibilities. We also suspected that the source might be lower down at the Rados level, particularly given the cluster's imbalance, though we lacked clear evidence. So we split our efforts there to look at Rados gateways, load balancing system, and the core Ceph cluster. Compounding this, after returning to service from the electrical works, we had hardware failure leading to a week-long outage of our OpenStack cloud service. This meant further splitting our resources to resolve the S3 service and get OpenStack running again. For a small team, these splits were costly. Now, with the benefit of hindsight, we have a snapshot of the problems at that time. The cluster was severely imbalanced, and hardware failures only made this worse, with the loss of another full storage node by another half a node shortly after. Degraded objects restricted the balancer to only 16 days of operation over a span of 100 days. This imbalance, combined with misplaced and degraded objects, prevented auto-trimming of monitor databases and effectively halted placement group scrubbing. As scrubbing did gradually catch up, inconsistent PGs were detected. Most repaired fine, but a few either took a long time to repair or took a few attempts. In hindsight, this was a relatively minor concern, but during an extended outage, it was actually an outage at this point, any issue that forces you to wait hours to see if it's resolved only adds to the stress and the pressure. RGWs were freezing up. Each time we restarted the daemon, we would see a lot of successful requests in RGW logs, and then a repeated sequence of starting new request with no matching completion log. Uploads were often very slow or timing out, and for some buckets, an rclone listing gave 504 gateway timeout with no output or sometimes a partial listing. And finally, RGW garbage collection was backlogged, not processing at all. At its largest, it reached millions of entries, which was worrying because we didn't have a benchmark for what was normal. Now I'll start in on how we tackled the problems. To set the scene, remember that Ceph often does its best work when being left alone. Tweaking settings here and there can easily hinder that self-healing, even though it feels meaningful to not just stand there but do something. At the same time, we have to recognise that any technology can go wrong, so it's important to look for what might be broken and take action if necessary. During times when a Ceph cluster is not functioning properly, there is a challenge to strike the balance between allowing it to self-heal and actively observing, investigating, and taking decisive action. It's a further challenge to hold this balance in a team of people with diverse skills and different views. Time is another confounding variable. It can lead to self-healing, but on the other hand, more problems can occur or simply reveal themselves. For example, the monitor database is not trimming while there are degraded objects is fine, unless monitor databases not trimming unless backfilling takes so long that the database grows so big that it might cause its own problems. When the broader problem persists over many hours and days, the underlying symptoms can shift. Finally, the people addressing those symptoms will have a changing perspective. And while we in tech often pretend otherwise, we're all thoroughly human. We overlook things, we forget things, we get tired. So with those things in mind, tackling the problem happened in stages. During the first week or so, excuse me, Our energy was spent bringing services across the centre back online after maintenance. And while this naturally included the S3 clusters, they were not our only focus. We made an effort to share some of the tasks with less experienced team members to increase their experience and to test our procedures. In this manner, the clusters were returned to service. S3 requests were unreliable with RGWs freezing up, and restarting the daemon got it to work, but only for a few minutes. We also had out-of-memory errors, but increasing the available RAM only served to increase the time before OOM. We rebuilt one of the nodes, but that didn't help. We wondered if there was a memory leak. By the end of that week, with OpenStack back online, and when the Ceph problems persisted, and in some ways worsened, our focus changed. At this stage, we knew there was either one complicated problem or multiple problems coinciding. Recognising that this could easily exceed our team's capacity, we engaged outside help. In trying to address the garbage collection backlog, we had some discussions on the Ceph Slack channel and raised a couple of items in the bug tracker, but much of this led down a long road with no clear resolution. New hardware was added, which assisted with low capacity in some racks. While browsing the web on the weekend, I encountered a script called upmap remapped. I learned about the upmap table and resolved to use this script once degraded objects were backfilled. We found out about emergency support services, and while we considered that option, we were graciously offered some gratis professional advice about getting backfilling under control. We learned that the upmap table is safe to use even with degraded objects, so we didn't need to wait for backfilling before running it. So after much discussion and hand-wringing, legacy rewaits were all reverted to 1 to allow the automatic balancer to manage placement, and immediately afterwards we employed that script to set all existing placements to remain, allowing degraded objects to be the only ones targeted for backfilling. This rapidly led us to no degraded objects, a great milestone for data integrity. The balancer was able to begin work again, and better still, this was controlled, because at any time the balancer can be disabled or given a lower target misplaced ratio. Shortly before degraded objects were resolved, we stopped seeing memory exhaustion on the RGWs. Apparently this was a symptom and not a problem in itself. Now we'd made some good improvements. We finally had backfilling under control and degraded objects resolved. Misplaced objects became a non-issue, and scrubbing started to catch up and find inconsistent PGs to repair. The situation was not yet resolved though. We still weren't entirely sure which layer the problem was in, and outside help began to give diminishing returns. We restarted all OSD daemons, one node at a time, to no effect. We also started running Rados LS sequentially against every PG to compare the nature of the output. We noticed that S3 put requests were much faster, likely due to improved balance. They were still unstable though, with RGW daemons freezing. The uploads often reached 100% and then got stuck there, never emitting the final confirmation message. Garbage collection was still stuck. We got lost down a rabbit hole of too many open files errors and explored some ideas for manual work to clear the backlog. We thought to use Rados list OMAP keys to check for whether data was actually present and use Rados commands to delete it, then stop all the RGW daemons and delete and recreate the log pool. We weren't confident enough in this idea to progress it far. External help was turning up fewer leads at this point, and our own efforts were not getting us closer to resolution. By the Wednesday night, we were all feeling frustrated and worried we might be stuck troubleshooting this for a long time. A key stakeholder meeting was being held on Thursday morning, so we prepared yet another set of words for various managers to use in describing the safety of the data, the service still being offline, and no estimate for return. And then, 1 hour before the meeting, we found it. The sequential Rados LS operation turned up a set of placement groups which failed to respond. Examining them with PG map revealed a single OSD shared by all of them. We restarted that OSD and everything fell into place. The meeting we'd been unhappily preparing for turned into a triumphal return to service conversation, and we all breathed a sigh of relief. At this point, there was a sense of anticlimax. Could it really have been one stuck OSD that brought down the entire service? Really though, it was a combination of factors. Cluster imbalance, skills and experience gaps, and communication and procedural issues. It became clear to everyone involved that while there may have been some single points of failure, we managed the situation as well as possible under the circumstances. The important thing was then to learn from the experience to make future issues easier to address and perhaps prevent. So with that in mind, we performed our post-incident review, and here are some key outcomes. Firstly, when coming across a problem, consider the possibility that symptoms you see might not be the whole story. They might be from the root cause, a proximal cause, or a knock-on effect. So you could spend a lot of effort digging very deep into one of them and find that it doesn't resolve the main problem. Therefore, decide how much effort to spend on any one before moving on to another. This takes a judgment call at times, so bring in the relevant people to help decide on this at regular intervals. Also, spend some effort deciding which symptoms to investigate first. In the modern age of remote work, different people in different places often interpret situations and even the same set of words differently. We are working with complicated systems, and when one person says kick the OSDs, they might mean reboot the host machine. Someone else might hear that and run Ceph OSD down and up again. This exact confusion hurt us, because even though we thought we had restarted all daemons, in fact we hadn't. So be very clear about what you're doing. Use whatever procedures you already have and create some more if necessary, but don't bog yourself down with them. They're supposed to support operations, not hinder. Pay attention to the people involved. This is a good idea all the time, but it's even more important during an incident. We operators respond in a variety of ways when our precious uptime is affected, because it's a point of pride when we feel like we're letting ourselves and the world down. Remember though, that for most computer systems, nobody dies or is even hurt or injured if it's offline. So we need to hold the balance on one hand, that most incidents are not life and death, and on the other, give due respect to the system and its users and get it working properly again as soon as possible. But firstly, say it out loud to each other. This is not life and death. Working long hours can be okay for a short time. Beyond a few days, the quality of that work will drop. Giving team members permission or even encouragement to finish their day on time can mean they're fresher tomorrow, sometimes with new ideas to solve the problem. Plus, we know that Ceph is very good at looking after itself, so a night of uninterrupted backfilling can be a good thing. When the dust settles, it is tempting to get back to regular work. However, we have found valuable lessons in post-incident reviews. Write down what happened, what was done in response, ways to make things better next time, and try to resist the temptation to blame someone. There is plenty of material available on why blameless post-mortems are a good idea and how to do them. Ceph operates better when in health okay, much of the time. Databases automatically trim, balance, and therefore capacity is managed, and admins are not constantly stressed, or worse, ignoring warnings because of alert fatigue. It also means that when health warn does occur, no arbitrary steps are required to decide whether to respond. So at least the first response can be quite straightforward. The question then is how to achieve and maintain this. Well, the warnings are often quite informative, particularly when you use self-health detail and follow the messages to logs and system status, including increasing log verbosity where needed. You might need to add more hardware, increase the disk space for your monitors, restart stuck daemons, or fix a networking problem. If you're confident a warning is not a major problem and will take some time to resolve, you can use Ceph Health Mute to silence it. On a related note, there are things which will not show up as warnings, which are still helpful to fix. Constantly leaving them until later adds technical debt, which comes back to haunt you when you least want it. Some zero-weighted OSDs, hosts with missing or failed drives, or other anomalies are good to find and fix. Cast a curious eye over the parts of your cluster and look to the dashboard and other metrics and observability tools to find these anomalies. Data resilience is crucial, so backfilling degraded objects is a top priority. Nearly as important is cluster balance, which impacts performance and capacity as the fullest OSD limits overall capacity. Letting the automatic balancer remap objects helps here. However, during major changes like adding hardware, crush map updates can cause a surge of misplaced objects, straining performance. Using the upmap table is key to controlling cluster balance, ensuring degraded objects are prioritised while preventing performance issues. It's important to get to know your cluster, particularly if you didn't single-handedly build it. Record typical metrics regularly on everything. Knowing that it's typical to see a few million entries in the RGW garbage collection queue is helpful when it's at that figure, as it was for us, and we should have known, but we didn't. And so is knowing when the monitor database, being at 20 gig, is an anomaly because it's normally between 10 and 15 on your cluster. This is an important backdrop to detecting anomalies because you will have data to compare against. External people can offer some very helpful perspective. They often cannot see all of the details of your setup, but it still amazes me how willing people are to read enough detail to offer insightful suggestions. So in the first instance, find out who those people are and where they are. They might be in your workplace or in your industry, or they might be in the Ceph community. Plus, of course, professional support is an important option to remember. It's far easier to establish those relationships in normal times, so they're readily available in times of trouble. In closing, I'd like to acknowledge some key people who helped throughout this incident. Firstly, Luca Civigni provided much needed perspective at times and ideas for how we might proceed. He in turn received support from Enrico Bocchi. The Ceph community helped us channel our efforts in the right direction and avoid some dead ends. Finally, Dan van der Stier gave us the confidence to start using the upmap table. Thank you to all of you. Happy to take questions, and you're welcome to have a quokka if you ask a question. There's microphones here. Might be easier to hear. I also can't see you very well.
Do you monitor OSD latency in any way, beforehand or afterwards, after your incident?
Afterwards, yes.
Beforehand, probably not.
No.
Okay.
Did you find a smoking gun reason with that one OSD?
No, we didn't. Because when we literally restarted it, we didn't even have to take it out. We just restarted it, and it came up fine. Yeah, it was frustrating. That tracker that was on the slide in the yes moment, that tracker is still open, so hopefully that gets resolved at some point. That's the Rados waiting infinitely.
Another question. You always said that the Rados gateways were failing after requests, but have you tried to start a Rados gateway without any access to the users, just to keep the daemon running?
As in turn off the load balancers and stop access to the Rados gateways?
Or just exclude a single gateway from the balancers?
We inherently had that because we have garbage collection RGWs that always have no user access, and so we did know, in hindsight, looking back, we did know that those ones were fine. Well, they appeared fine, they had no errors, and certainly weren't running high on RAM.
A curiosity about the VSD that was misbehaving. So that VSD did not get reported in any way from Ceph Health?
No, sadly.
After the incident, did you implement any logging system to keep track of the logs, like to analyze them?
Yeah, that's a work in progress. We've started taking snapshots of a whole range of things of the cluster now, but it's a bit ad hoc. And I was talking to somebody this week. I've got notes on following them up on how to simply take that and enhance how we visualize that and track it. But it's... Sorry?
run provisions for future like usages, like understand better what are the behavior of the cluster and so on, like analyze the data you kind of generate.
Yeah, I suppose that's always a work in progress. We haven't got anything specific on data analysis on the cluster.
I wonder what was the core issue of the failing cooling system?
Our cooling system, so we're tenants in the building, but we're on good terms with the people that run it. Our cooling system has a fail-safe configuration, and by safe I mean it keeps itself safe, not the computers in the building. There was a communication failure between two pieces of the building management system, and so they both panicked, something like a split brain situation, I guess. They panicked and shut down the cooling.
Thank you.
And yes, they've improved that since.
Which version of Ceph you were using and how did you deploy it? Was it Ansible based or Ceph ADM? I guess it depends on the version.
I'm pretty sure we were at Quincy by then. Yeah, I reckon we're at Quincy. And this is Puppet to deploy and manage the machines, and packages, and just Ceph volume to deploy the OSDs.
Do you think the problem had something to do with the Ceph version, or it was just maybe hardware?
So we don't know why that daemon on that OSD was failing to respond. And yes, maybe there's a bug in the OSD code that's contributing to that, or you might say there was a problem with the hard drive underneath it, but since we've restarted it, we've had no problems ever since. So it's a bit of a mystery.
Okay, thanks.
So I'm curious about your use of the upmap rebalancer. So you learned that is a tool that's useful for you. What are the are you using that on a regular basis these days on a day-to-day business? And what are the criteria for when to use it?
So not on a day-to-day basis, but in certain situations it's very helpful and it's very reliable. So the most recent use of it was when we needed to add a whole lot more hardware to the cluster because of data growth. We set no rebalance or no backfill. I forget the settings we flagged to stop the data moving. Added all of the hardware, set weights to 0. And then when everything was up and peered, we then set all the weights to 1 effectively, which then suddenly caused a whole lot of misplaced objects. And then we immediately applied the remap script to set them all back to say, no, data stay where you are. And then the balancer can come along and slowly start migrating data to the new drives. So yeah, it's a way of, if for whatever reason outside of your efforts or the balancer's work, misplaced objects go sky high, then you can just say, no, stop, keep all the data where it is, and then the balancer will come back on and slowly move that data. Because apparently it looks in the upmap table for entries to delete or for movements to make.
Yeah, just to mention on that, we also do that even if we just swap a single drive. Because when you add a new drive, you have just a failed drive, you wait until the data is recovered, you bring it back in, you have the misplaced data, and all the misplaced data will influx to that one particular drive. So you use upmap in that case as well, because you kind of will not stress this one hard drive as much as it would be if you don't use upmap in that case. So upmap, really use it it's a great way to have your cluster in a much better state.
Yeah, thanks. I actually like to talk to you about that afterwards because I'm not quite following you in my current state. All right, thank you, everyone. Before I finish, I will make the connection with the quokkas. The name of our supercomputer is Photonics, which is the genus in which the quokka lives, and it's a native animal in Western Australia. And I really do want people to take these. So if you've got small people in your life, come and take a quokka. But thank you.